Alright, welcome back. This is day 4. We're going to be looking at Newton's second law. Newton's second law can be summed up in one equation, but we'll be looking at the whole law itself. So here we go. So Newton's second law states that all the forces acting on an object can be determined based on the mass of the object and the acceleration that the object is going. So there's a relationship between mass and acceleration that relates to the overall force acting on an object. And that overall force we can just call net force. And that net force is equal to the mass times the acceleration. So the mass times the acceleration, or F equals ma. And this m and the a is mass times acceleration. So when we're looking at Newton's second law, it's actually an equation of all that's going on in the problem. Now you can have multiple forces acting on it, but when I talk about net force, I'm talking about like throwing a net out, grabbing all the forces together, and finding out what the overall force is acting on the object. So we're going to be looking at a simulation. It's a little bit different than yesterday's simulation, but it's a really good one because it shows you a graph too of mass, acceleration, velocity, and position, along with the force that's acting on the object. So it relates all of everything you've learned so far together in one thing. And this equation is important when you're doing it. So here we go. So you're going to go to forces in one dimension. Okay. You're going to click on it. You're going to download the program, and then you're going to run the program. So this is the program. When you run it, notice it looks like the tree, looks like the house that we've seen before with the moving man, but this is a little bit different. Okay, it's a little bit different. We're going to move the filing cabinet across the room, across the station. So I want you to go ahead and put the acceleration graph available. We can also put the force graph. So we have a force graph, we have the acceleration graph. Alright, we're not going to have a friction on there, so don't stress. If friction's on, let's turn it off. Okay. You can turn off friction. So let's go ahead and go to the applied force here, and let's give him a nice force. And then we can just hit go and see what happens. So we're going to hit it go, and we're going to see that the filing cabinet moves across the counter. Pause. Notice my force is right here. My acceleration is right here. Okay? So what you do is you take your acceleration, and your force is going to be dependent on your acceleration changing. So let's see what happens when we bring it back. Okay. Let's start over. Clear. Yes. Alright. We're going to move him. Nope, we can't move him. Alright, so we're going to apply a force as it's going. So we're going to apply a force as it's going, and we're going to find out what happens. Notice we have a little bit of a diagram up in the right corner. So this is our forced body diagram, a free body diagram. So let's give it initial. Alright. Oh. Notice I can do things to the graph where I'm changing my force and affecting the acceleration based on it. Oh. Apply larger. I want to stop it at 0. Whatever. You see how it can be fun. So I want you to play with it. Notice that there's a relationship between my acceleration and my force. Okay? When I go up in acceleration, I go up in my force. When I go down in my acceleration, I'm applying a negative force, opposite direction. Okay, you also have a refrigerator. You also have a textbook, okay, a crate, and a sleeping dog. So I want you to do all 5 of those for the lab. I want you to follow the lab. It will give you instructions on how to do this. And I want you to have fun. I'll see you guys at lab day.